This question looks completely harmless at first glance. You are given an nth degree polynomial, one value at 0, and a bunch of integrals that vanish. No scary limits, no crazy functions, but hidden inside, this is a powerful idea that JEE loves testing: how polynomials behave under multiple integral constraints. In this video, I won't use any advanced maths, no engineering shortcuts. We will solve it using pure class 11th and class 12th ideas. And by the end, you'll see why the final answer comes out so cleanly. So with that, let us jump ahead and solve this crazy hard question that appeared in FIITJEE All India Test Series. So here we have a polynomial, alright. It is an nth degree polynomial, and so we have assumed the polynomial to be an x to the power n, an minus 1 x to the power n minus 1, and so on a naught. Alright. Now this is the next condition given to us. F0 is 1 upon root 3. What does this imply? This implies that a naught is equals to 1 upon root 3. Alright. So this is the implication of this particular condition. Now what else do we have? We are given that x multiplied by fx, the integration of this from 0 to 1 is 0, and similarly this and this. There are n different integrals given to us, and the values of all those integrals are zeros, and we are asked to find out this particular value. So that is the question. I hope it is clear. All right. Since we have x to the power 1 fx, x square fx, x cube fx, x to the power n fx. So okay, what we are going to do in this video is we are going to solve this problem using two methods. First method is a very brute force and naive way of solving it, brute force or naive approach, and the second way is very elegant and creative. All right, so let us go through this method first. So since we have x square, x cube, x power n in the integrals given, so let us consider integral 0 to 1 x to the power r fx dx. So now this is integral 0 to 1 x to the power r, and you know fx is all right. Let us put the value of fx here. So you have an x power n plus an minus 1 x power n minus 1 plus and so on plus a1x plus a naught. So these are all 0 for all r is equals to 1, 2 and so on n. All right. This is what is given in the question. All right. So now let us try to evaluate this integral. All right. So now we have to integrate this particular thing. So let us check the first term. When you check the first term, this is an, you have x to the power n plus r. When you integrate that, you'll get x to the power n plus r plus 1 by n plus r plus 1. Similarly, for the second term, after integration, you'll get x to the power n plus r upon n plus r plus and so on, plus for this particular term, you have a1, so x to the power 2 plus r upon 2 plus r plus a naught, so you have x to the power r, so this is x to the power 1 plus r upon 1 plus r. So this is the integration. So now you have to put the limits. So the lower limit is 0, upper limit is 1. When you put the lower limit 0, the entire expression goes to 0. So let us put the upper limit. So when you do that, you'll get an upon n plus r plus 1 plus an minus 1 upon n plus r plus and so on plus a1 upon 2 plus r plus a naught upon 1 plus r. This is equal to 0. So this thing is 0 given in the question. So, and this holds good for r is equal to 1, 2 and so on n. So let us put r is equal to 1. Then you'll get an upon n plus 2 plus an minus 1 upon n plus 1 plus and so on plus a1 upon 3 plus a naught upon 2 is equal to 0. Now put r is equal to 2. When you do that, you'll get an upon n plus 3 an minus 1 upon n plus 2 plus and so on plus a1 upon 4 plus a naught upon 3 is equal to 0. Similarly, when you put r is equal to n, you will get an upon 2n plus 1 plus an minus 1 upon an minus 1 upon 2n plus and so on plus a1 upon n plus 2 plus a naught upon n plus 1 is equal to 0. So if you observe, you have n equations and you have n different variables. A naught is known to us, all right? A naught is known to us. So from a1 to an, you have n different variables. Now you have to solve this to find out all the variables, all right? So that is a very difficult task. You cannot solve this. Understand? You cannot solve this. So what should we do now? So how can we find out this value? So, okay. Now, how do you solve these n equations? When you have n equations and n variables, okay, so you'll construct a matrix an minus 1 and so on a1. A naught is known to us. It is 1 by root 3. We have figured out already. All right. A naught is 1 by root 3. So this term will come. This term will come here. This term will come here. All right, and it will become all negatives. So here you will have 1 by n plus 2, 1 by n plus 1 up till 1 by 3. So in the first row of the matrix, you have 1 by n plus 2, 1 by n plus 1, and so on. Here you have 1 by 3. Similarly, in the second row, you have 1 by n plus 3, 1 by n plus 2, 1 by n plus 3, 1 by n plus 2, up till 1 by 4. Similarly, okay, this has to be equal to this side. This side, what you'll have minus a naught by 2, minus a naught by 3, minus a naught by n plus 1. All right, minus a naught by 3 and so on, minus a naught by n plus 1. So you have constructed this. So how do you solve this system? So when you have 3 by 3 matrix, you will find the inverse of this matrix and you will send it to that side. Then you will get all these, the values of all these parameters, matrix inversion method. So similarly, for n by n matrices also, you can find out inverse, and that is outside the scope of JEE. So you get to solve these system of equations using matrix inversion method for any degree in your engineering studies. All right, but this way you will not be able to mark your answer in JEE, and see how cumbersome it became. This way of solving became very cumbersome. All right, so how do you solve it? So let us see how this can be solved. Second method. All right, this is a very elegant and beautiful method. So let us say f of x is sigma p is equal to 0 to n ap x to the power p. All right, this is what we have. This is f of x, and we know a naught is equals to 1 by root 3. Now we have integral 0 to 1 x to the power r f of x is equal to 0 for all r is equal to 1, 2, 3 and so on n. This is also given in the question, correct? So now what we can do is, we are asked to find out integral 0 to 1 fx dx divided by integral 0 to 1 f square of x dx. So this we have to find out. Since we have to, okay, let us take this, let us consider this. So integral 0 to 1 f of x whole square dx. Now let us split this integral right like this. So this can be written as f of x multiplied by f of x dx. Now instead of 1 f of x, you can substitute this particular thing. All right, so this becomes integral 0 to 1 fx multiplied by sigma p is equal to 0 to n x to the power p ap times dx. So this ap is independent of the summation. All right. No, this AP is a constant. So, okay, let's do one thing. So now let us expand this. A naught plus A1 x power 1 plus A2 x square plus and so on an x power n dx. Alright, this is what we have. Now let us take out this particular integral. A naught integral f of x dx. So this term is separated. Now we have only these terms. Alright. So the first term is simply A1 integral 0 to 1 x times fx dx. Alright. And the second term is A2 integral 0 to 1 x square times fx dx plus and so on, plus nth term is an integral 0 to 1 x to the power n fx dx. Now see the beauty of this question. So this particular quantity is 0. It is given in the question. This is also 0. This is also 0. So all these integrals will evaluate to 0. So the only thing left is on the left hand side we have integral 0 to 1 f of x whole square dx is equals to, on the right hand side we have a naught 0 to 1 fx dx. So if you bring this to right hand side, you will get 1 by a naught is equal to integral 0 to 1 fx dx upon integral 0 to 1 f of x whole square dx. And this is exactly what is asked in the question. What is that 1 by a naught? We know a naught is 1 upon root 3. Alright, so 1 by a naught is simply root 3. So the value of this is simply root 3. Is this method not elegant? What is the key idea here? The key idea is to write f of x whole square. First, to consider this particular integral and then writing f of x whole square as f of x multiplied by f of x and leaving one f of x as it is and substituting this particular summation for the other f of x. See how beautiful the idea is. So this question was there in FIITJEE AITS. Alright. Now that's all for this video. So if you liked the method, if you liked this particular question, do not forget to give this video a thumbs up, share it with your friends, subscribe the channel for more such content, and you can join my Telegram channel through the link in the description. And there are a lot of fantastic videos on the channel. Do check them out. And if you have any queries, comment section is the way to reach out to me. Thank you. I'll meet you in the next video. Till then, take care.